Hey everyone, you should have just received your quiz back that you took yesterday. And so I want to go over how it was graded with you and go over the correct answers with you today. So you should see a score on the top front of your quiz. That score is out of 13 possible points. There were also 3 extra credit points available if you did really well on the 2 questions at the end. So there was a possible maximum score of 16 out of 13. So if you got over 13, great job. You did amazing. I'm not going to go through what score you need for a 2 or for a 3 or a 4, because we just finished a unit on percents recently, right? So you should be able to figure out what 90% of 13 would be, what 70% of 13 would be, and figure out where your grade falls in that 1, 2, 3, 4 grade range. So let's go through the answers here. The first question says, let's say you have these 4 cards, you're playing the integer card game. What's your score? Just add them up, right? So my strategy is always add the positives and negatives separately, and then combine those in one last move. So these 2 right here, -8 and -2, just add them as if they're a positive. That's 10, but we throw a negative sign on there. And then here we got a 2 and a 9. That's going to make 11. And so -10 plus 11, we subtract them. 11 minus 10 equals 1. And the positive number was the one with greater absolute value. So there's our answer. That was worth 1 point. If you got that right, you didn't have to show any work or anything. As long as they could find a 1 somewhere in this region of your paper, you got a point. All right, the next part says, let's say you had these 4 cards, and then it's your turn and you pick up a 5. And you got to tell me what would be the best card to discard out of the 4 that you originally started with, because you're not allowed to discard the 5, in order to get the best score possible, closest to 0. And so the answer is you want to discard the 9. And that was worth 1 point. Just getting the fact that you had to discard the 9, 1 point. But then this is really important here. It says explain in words or by showing more calculations how you know this was the best card to discard. Doing a good job of this was worth 2 more points. The absolute best, surefire way to get full credit on this part was to just show me the calculations for all 4 possibilities. So you could have chosen to swap the 5 for the -8, and then you'd have 5 plus -2 plus 2 plus 9. And let's see here, 5 and 2 make 7, 9 is 16, minus that 2. So doing this gets you a 14. Let's see here. You could have chosen to swap the 5 for the -2, and then you got -8 plus 5 plus 2 plus 9. And let's see here, 9, 2, and 5, they make 16 minus 8. It's going to leave you with 8. You could have chosen to swap the 5 for the 2. That gets you -8 plus -2 plus 5 plus 9. The 5 and the 9 make 14. These make -10. So that's going to come out to 4. It's pretty close to 0. That one's not bad. But if you swap the 5 for the 9, you're going to get -8 plus -2 plus 2 plus 9. And let's see here, the 2 and the -2 make 0. Wait, no, it's supposed to be swapping the 5 in. What am I doing? What are you doing, Mr. Thomas? Hold on. All right, the -2 and the +2, they make 0. And then the -8 and the 5, they make -3. And so that's the closest you can get to 0. So showing me all that math was a surefire way. If you wrote out in words, it needed to be super rock solid. One of the things that some people lost a half a point for was saying, oh, I definitely wouldn't get rid of the 2 or the -2 because they make 0. That's not necessarily sound reasoning to not get rid of the -2 or the +2. You just because they make 0 together doesn't necessarily mean there's no chance that they absolutely have to stay in your hand. What if your hand was like, I don't know, -1, and then you had a +10, a -10, and a 2. Okay, let's pretend that's your 4-card hand. -10 and 10, they make 0. and then the 1 and the -1 and the 2, that's going to leave you with a score of +1. And then you draw a 9. You definitely wouldn't want to switch that 9 for this -1 for that 2. That's going to make your score really positive. If you switch it for the -1, it's going to make your score 11. You switch it for the 2, that's going to make your score 8. But if I switch it for that 10, it's going to make my score 0. Even though the 10 and the -10 make 0. So like just stating the fact that, hey, they make 0, I'm not getting rid of them, that's not good enough. And so, I might not have given you feedback. You might look at your written thing and say, I didn't get full credit here, because full credit on this question would be a +3, 1 for getting the right answer and 2 for your explanation or your work. If you didn't get full credit, just know that there was something about the way you showed your work or the way you explained your answer that wasn't quite solid. All right, next, you're supposed to look at this vector model here and first write me the equation that this vector model represents. And so equations have equal signs, equation, equal. And so you needed to have the 3 addends. Those are the numbers being added, which here is going to be a -3. This one is a +8 because it's a vector going 8 units in the positive direction. And then this one is +2, 2 units in the positive direction. If you just wrote this is only an expression. This is not an equation. And so this was worth 1 point out of 2. Filling this box in correctly is worth 2 points. In order to get 2 points, you also had to give me equals 7, the sum, the answer right here, right? And then the next box says, what is the additive inverse of the sum? This is the sum. The additive inverse of this, or the opposite, is just its pair on the other side of 0 on the number line, right? If it's +7, the additive inverse is -7. You got -7, the additive inverse is +7. So what I needed in this box was a -7. So 2 points for getting this equation correct and 1 point for getting this. If you put this sum here in this box, because I guess maybe you didn't understand what you were supposed to do. You thought the answer was supposed to go in this box. I gave you points as if you had filled in box A correctly, but then you got box B wrong. So I tried to grade it as fairly as I could. All right, these you just had to give me straight up answers. You should have got -6 here, -7 here, 12 here, and 0 here. These were worth half a point each. So if you got all these right, you should see a +2 in this region. All right, on to the Lake Tahoe water vector model one. You needed 2 things here. You needed an equation and a vector model. And the equation needed to have the answer in it, right? That's what equations are. If you left out the answer, you only gave me an expression, not an equation. Also, I wanted to have an equation. N means 1. And so I'm nitpicking here on you a little bit, but I wanted the whole thing represented in one long equation, not like a little piece of work here and a little piece of work here and a little piece of work here that winds up getting the answer toward the end. That's I took like half a point off if you did that rather than one good equation. So I'm seeing that the first thing that happens to the water level is it dropped 4 inches. So I'm thinking a change of -4 with that. So I want to add -4. You could have started by writing 0 and then plus -4, or you could leave the 0 plus part off and just start with -4. Both of those work in this case. All right, and then next I see that it fell another 6 inches. So I want to add another -6 here. Then the next thing I see is that it rose 3 inches. Let's go up. So let's add 3. And then the last thing I see is it rises another 5 inches. So I'm going to add 5. And if you add all this stuff up correctly, you should arrive at -2, meaning the water level ends 2 inches lower than where it started. And so I would have liked to have seen a word conclusion here that says the water level in Lake Tahoe over 4 years changed by -2 inches or was 2 inches lower than it started, something like that. So the vector model should start at 0 and go to -4 for your first change you're representing. You can label that with a -4. And then we're going from -4 down 6 more, which gets you to -10. And then from there, we're coming up 3. And so that should get you to -7. And I did want you to be pretty accurate with this. There were a couple people I had to ding half a point or a point because their vectors weren't matching where the numbers really should be on there. So this is 3. And then the last one is 5. And so we want to make sure this ends right at around -2 because we already know that's the answer. We did the math. And mine might be ever so slightly too high, but not enough that I would take a point off of it. And then I appreciated the people that circled the answer on the number line. So this was worth four points here. Getting this equation correct with the correct answer was worth 2 points, and getting this vector model correctly done with the vectors in the right spots and all the pieces in the right spot was worth 2 points. And there was a lot of partial credit given here and there for little things that weren't quite right. All right, lastly, on the extra credit. So you're adding these two numbers that we're gonna call P and Q. And you're given enough facts to figure out what you're being asked here. The first thing it tells you is that P is greater than 0, AKA P is a positive number. And it tells you that Q is less than 0, AKA Q is a negative number. So you're adding a positive and a negative. That's what you know so far. And then it tells you that the absolute value of P is less than the absolute value of Q. Or in other words, P, the positive number, is like smaller than Q, the negative number. When I say smaller, I throw quotations, right? Because positive numbers are always bigger than negative numbers, but I mean smaller by absolute value, like just the digits itself are smaller. And so just that information is enough to tell you, oh, then the sum should turn out negative, right? If we add a positive and a negative, but the negative number is bigger, the answer turns out negative. That's all I'm checking to see if you can understand here, just writing it using all these symbols to see if you can kind of like piece together what they all mean. So here you got 1 point for just telling me negative. You didn't have to do anything else, but just get this right, that it was negative. So even if you 50-50 guessed positive or negative here and you got it, lucky you. Then here, it was a lot of just judgment calls on my part. I read what you wrote, or I looked at your diagrams. If I thought it was rock solid, you got 2. If I thought it was really good, but maybe missing just a little piece, 1.5. If I thought it was 1, and if I thought maybe you got just a little piece of it, I gave you half a point. My favorite ones were the ones that just showed me using vectors. And I'm not saying these are the only ones that got full credit, but this is how I would have done it. I would have just drawn a number line. You don't even really have to label it. You just got to tell me where 0 is. And shown that, okay, so I've got a P vector that's going in the positive direction. And let's say it's like this. Doesn't really matter. I could just label this as P. Well, Q, when I add that to it, I know that its absolute value is greater than P. And remember, absolute value and vector length mean the exact same thing. So in other words, it's a longer vector. And so maybe it goes like this. If you just drew this, I'd probably give you like a 1.5. If you just threw some words on with it to explain it and say that like since Q's absolute value is greater, its vector is longer, thus, I'm going to use the word thus because I remember last week everybody was all like, who actually says thus in class? Thus, the last vector ends left of 0, right? And if you're left of 0, you're negative. You didn't have to say exactly that. That's just how I would word it. Okay, so this is the last thing that will go in your SBP grade book for this semester, for this quarter. Luckily, the vast majority of you did it really great on this. There was lots of 4s and stuff. So I'm glad that we were able to get a nice little boost to our grades before we submit those. And this is the last thing I'm gonna require of you for this semester. If you have any outstanding, like missing work that still needs to get turned into me, you can give that to whoever's in the classroom today or on Thursday and Friday. I will come to my classroom probably Friday afternoon and pick up whatever's there and put it in my grade book. I haven't graded the homework that you turned in yesterday yet, but I have a sneaking suspicion that there's going to be a lot of no-name work in that pile because I wasn't there to bug you to make sure your name was on it like 92 times before you turned it in like I normally do. And so if that turns out to be the case, I'll drop some of that stuff off into the no-name bin before, like as soon as I can, I guess. And if you see you got marked missing on that, check that no-name bin. Check it anyways. There's a lot of stuff in that no-name bin. If you're missing something from my class, go see if it's in there, put your name on it, and give it to whoever's substituting for me, and I can pick it up on Friday and make sure it gets in the grade book for you. If you do any work online, any old Desmoses that haven't been done or whatever, make sure to send me an email and tell me that you completed it so I can go check it and give you credit. Okay, I'll accept any late work you got at this point, so we can get it in the grade book. For the rest of this class period and for all of the block period, I'm going to ask that you watch a movie called Hidden Figures, a movie that I would imagine probably a lot, maybe more than half of you have already seen. So it's a movie about 3 women named Katherine Johnson, Dorothy Vaughan, and Mary Jackson. So these are 3 Black women who worked for NASA in the 1960s. In the 1960s, that's time back when this country was still segregated in terms of where people could work, what things people could do, what bathrooms they could use, what water fountains they could drink out of, all that stuff. And let me stop sharing. And these women come to work for NASA as what we back then were called computers, obviously not electronic computers like we know now, right? People who did computations, computers. And they're entering a work environment that is not only, overwhelmingly white, but also overwhelmingly male as 3 Black women. And they come in there and they get, discriminated against by the people they work with initially and, sort of dismissed as not belonging in what they're doing. And they prove a lot of people wrong by doing some really amazing mathematics, solving some things that were not solved before they walked in the door, and really, proving what they could do. And they did this for a country that was waging what we called the space race in the 1960s, where America and Russia both really wanted to be the first country to put a person on the moon. And we were right in the heat of that. And you have these 3 Black women who are fighting to make this country, great on the world stage, while at the same time not being treated fairly by any means by the same country that they're doing this work for. And one of these 3 women in particular, named Katherine Johnson, really stood out as one of the mathematical giants of modern times. You might not think of the 1960s as modern, but compare that to like these ancient Greeks that we talk about a lot in mathematics. Her, beyond like some of the other amazing mathematical things she did that you'll see in this movie, what impresses me the most about her is her attention to precision. If you look around my classroom, there's at least 2 things on the walls that say that one of the mathematical standards or like ideologies that we should follow is attend to precision, or that means to pay attention to precision. And Katherine Johnson embodies that, maybe more so than like any other mathematician that I'm aware of, because also another thing that was happening in the 1960s is computers, what we actually know as computers, electronic computers, were becoming like a thing. And NASA is one of these first organizations to adopt this new technology. And they're using these computers to replace human computers to do computations that are going to put people in space. And these computations have to be so accurate and so precise. They're off by a little bit of a decimal, and the space rocket's going off where we don't want it, and all sorts of bad things can happen, right? Katherine Johnson, her calculations were so accurate and precise that she's looking at math she's doing by hand and comparing it to what the computer's doing and saying, mine's more accurate, mine's better, to the point to where like people that were really high up in NASA that relied on these calculations were like, I don't want the calculations from the electronic computer. I'm only going to trust the numbers if they come from Katherine Johnson. And I want you to keep that idea in mind anytime me or any of your other future math teachers are saying, hey, you got to double check your work, or you got to make sure that answer is exact, because somebody like Katherine Johnson knew that was the case. And if she wasn't that precise and that exact, some really dangerous and unhappy things could happen to some astronauts in space. So yeah, I'm going to ask you to watch this movie. You should get, part of the way into it in this class period, 30 minutes into it, however long is left in this class period, and then you should be able to finish it on your block period tomorrow or Friday. And then I want you to have a really happy, safe winter break. I hope you get to spend some time with some family, celebrating whatever holidays you and your family celebrate. I hope you eat lots of good food, and if you're traveling, please do so safely. Especially keep in mind COVID's still a thing. So, just be safe. Come back to Willard in January, happy and healthy, and hopefully I will too. And I'll see you then.